And we are live. Welcome back, everybody. This is a very exciting episode today because usually this YouTube channel is primarily focused on Cosmos, but I have the head of engineering today here with me, Patrick O'Grady from Ava Labs, right? And Ava Labs is building the Avalanche network. And if you guys have watched my last video where I compared Avalanche to Cosmos and Polkadot, you probably have a basic understanding of how Avalanche works. I also just checked with Patrick. I wasn't completely wrong with the things I said about Avalanche in my video, but there's some things that I'm going to ask him what I probably presented in a slightly different way. But yeah, first of all, Patrick, thank you so much for joining. How is everything going? And maybe you can share a little bit about your journey, your crypto journey, and what led you to work as the head of engineering at Ava Labs.
Yeah, sure. Thanks for having me. Excited to be here. I know you have a pretty cool audience, really interested in the multi-chain, multi-blockchain world. And so I think we share a lot of ideas. So it's hopefully not too crazy that I'd be on this show to chat about some of that stuff. Yeah, so I'm Patrick O'Grady. I'm the head of engineering at Ava Labs. I've been here for about 2 years. So I joined just after mainnet launch. Prior to that, I worked at Coinbase for 2 years. On a project called Rosetta. So if you've ever heard of the Rosetta API, it's like a way for Coinbase to integrate with different assets. That was my project. So I wrote all the code, wrote the specification for that. And then prior to that, I was just a normal engineering student at Stanford studying computer science. I actually grew up in the Midwest, far away in Wisconsin. Not a lot of blockchain going on there, so I wasn't super exposed to crypto until I came out to California. But my journey starts actually, I took a class from Balaji, who is the CTO at that, or CEO at that time of a company called 21. And so there was this big, there was this class anyone could sign up for, but if you signed up, you got a free 21 miner. So I keep this next to me. And so funny, it says this thing actually has a small ASIC running on top of a Raspberry Pi. And so mine's Bitcoin and everything like that. So that's really was my intro into everything blockchain and Bitcoin. And at that time at Stanford, you could either do rockets, AI, or crypto. And I tried AI for a bit. Turns out I'm just not super great at the math there, but really loved distributed systems and getting into that. And so, the rest is really history. I got super into crypto, distributed systems, and everything like that. And I was telling Cryptocito before the show started that early on, I think Cosmos and Tendermint were like really large pioneers in like the multi-chain, kind of blockchain community story, and some of the original ideas there around app chains or optimized chains. And so I got really familiar with that ecosystem early on. But, after going to Coinbase and working with different crypto ecosystems there, really started to form stronger opinions on what mattered to me, and went to Ava Labs as a result. Yeah.
What time frame was that, and what exactly was that thing that you said Avalanche really, like the vision for Avalanche really aligns with how I see crypto, or how?
Yeah. So I joined Coinbase in 2019. So right in the middle of a deep bear market into everything that was going on. I remember 2 weeks before I joined, Bitcoin went down to like $2,000 or something like that, or $2,500, and I was like,
I remember those times.
Coinbase just had like they hadn't laid off anybody like they did in this most recent time, but like half the engineers had just like quit over the last 6 months. So their team was like really far down, and I was like gearing up to join. I was like, well, like we're in it or we're out, so we'll just try this out and see how it goes. But yeah, so in 2019, then stayed there until January of 2021, and that's when I went over to Avalanche. And so, like I said, a few months after launch, and I had heard about it. When the original Avalanche paper dropped, like a lot of people had, around like some of the new ideas that they're bringing to consensus. So I was really interested in what that meant for a new layer one. But then the parts that really sold me and took me all the way were not only could you have a ton of participants, but you could still achieve finality very quickly, or even faster than some chains that had many fewer participants. And I was like, that was first of all, crazy conclusion. And then lastly, the generality of it. So not only were they launching with EVM support, which was interesting at that time, and frankly still is for a lot of different projects, but the idea that you could launch your own blockchain and have this like platform of platforms was, to me, the story that would be for the next decade of crypto. It wasn't just going to be about deploying a contract. It was going to be about building ecosystems and like empowering ecosystems to grow on top of kind of shared foundations.
Yeah, and it's amazing how fast this space evolved. I also remember 2017, 18, like that time. This was all just like a concept and like an idea, right? And now we have IBC in production for nearly 2 years now, transferring billions of dollars in value every single month. You guys just announced AWM, and I have a lot of questions around that. I think this whole like interoperability and also this modularity and shared security theme is becoming really big this year in crypto. Yeah, do you see?
Yeah, I mean, it's crazy to think like when I had the Bitcoin 21 miner, that was like back in like 2014, 2015, and like the whole notion was, yeah, you can like hook up websites, and they were going to try to add this like universal port on websites and stuff like that, that allowed you to like have like hook up your website and have like a micro payment protocol on your website. And so the notion was this little like 21 machine I had was serving as like a web server that you could pay to and then unlock certain functionality in the website. And that was like, that was crazy for Bitcoin 2015 when everything was super cheap. Like all the fees were really low. Like there was no Lightning. You could just like pay people. And it was like this awesome crypto native, like internet native payment protocol. And to think how many of the ideas had changed, like, and 2017, obviously, with the boom of like ICOs and everything like that, really funded a lot of the awesome development that I think people see today. But at that time, everything was just a piece of paper, right? You had to trust a team that like, yeah, this crazy idea, it's going to take a few years to get it out the door, but I promise when it gets out the door, it's going to be awesome. So yeah, I mean, I think everything that the community has done across all the different projects since that time, obviously there's been good parts and bad parts, but I think the good parts and what they've meant from the technology perspective has been really exciting. And I think how much the academic ecosystem has joined in recent years in particular has supercharged that effort. So,
yeah, fully agree. Yeah, also like the whole DeFi ecosystem. And I know you guys also have a head of DeFi at Ava Labs, so would love to also talk to him at some point to talk about the DeFi ecosystem on Avalanche. But yeah, since I mentioned the video earlier that I made a couple of days ago, I actually forced you to watch it to prepare for this interview. So maybe you can summarize some of your viewpoints about the video I made, and specifically towards Avalanche. And I think you also took some notes on things that I might not have gotten 100% correct. So maybe we can start off there.
Yeah, sure. So first of all, video, I mean, there's a lot going on in the Avalanche ecosystem. So, and I think one of the big things that we're going to try to do this year is really write down a lot of that information more clearly and make it easier to understand. So first of all, thank you for taking a stab at really trying to summarize a lot of the way that the system really works. So yeah, I just had a few small points just to clarify. First off, Avalanche consensus and everything that's running on Avalanche network. A lot of people get sucked into just the EVM part. And I think you did a really good job of kind of widening that scope and explaining. There's actually, the EVM is one part of it in deploying contracts to the C chain. But there's actually two other chains in the primary network, whatever that means, the primary network. And then there's also all these subnets, right? So the consensus mechanism is really what powers all of this to happen. And so every chain has its own instance of Avalanche consensus, and Avalanche consensus is this BFT based protocol or BFT support protocol, and a lot going on there. But I think the first thing that I want to call out was you mentioned that Snow consensus algorithm works very similarly to a DAG, and Snow consensus at a higher level is really just this really interesting approach to consensus that uses repeated subsampling to achieve fast finality and low network complexity. And it can be applied to both DAGs and to linear chains. So in Avalanche, the network, there's the Avalanche variant of Snow, which is applied to the X chain, which is a DEG. And then there's something called Snowman, which is applied to all the chains. So that's C chain, P chain, and most of the actually all the subnets currently run chains. So it's applied there. So people talk about Avalanche and Avalanche the network as mostly like this DEG-based thing, but actually I would say 99.9% of the current activity occurs on chains running Snowman, which is the chain-based variant of Snow consensus, which is just a interesting thing. But yeah, so you should think about them a little differently and kind of a little bit more detached than I think you explained them. Secondly, you mentioned a point about the X chain where Avalanche, the token, resides and where assets are created and settled. So Avalanche actually resides on all chains in the primary network. So there's a significant amount of tokens that were originally created on the P chain that have locked stake based on like the distribution stuff with the token. The X chain, there were definitely assets there. A lot of Binance activity actually occurs still on the X chain, and you can create what are called Avalanche native tokens on the X chain, or you can still create assets on the C chain too. So if you create some token or something like that, you don't have to create it on the X chain. In fact, most people create it directly on the C chain. The X chain will become, a more interesting place to create assets very soon because and this is something I think we'll get to later, Avalanche has this notion of subnets called elastic subnets, which let you stake community tokens to become a validator on them, and assets there have to currently be created on the X chain to be compatible with that. So just to clarify that, you can create assets there, but there's actually a few other places you can create assets. And then the last one was just something you didn't actually say, but just wanted to allude to was when you were talking about Polkadot, you mentioned that there were two consensus algorithms at play, one for their production and then one for their finality. In Avalanche, it actually works very similarly. We currently use a protocol for proposal called Snowman++, and that's decoupled from the finality gadget, which is just normal Snowman consensus. And so what this allows is for there to be like a processing tip that proceeds ahead of the actual finality line. The cool thing that our finality gadget does is it actually lets you though vote on the tip of the chain and finalize and vote on the entire frontier rather than having to finalize each block along the way. So under periods of like network stability, it can lead to recovery faster. It also means that typically there's less network communication to actually finalize each item. So there's my short interlude. But yeah, I think overall, I think it was mostly pretty good. Yeah.
Yeah, thank you so much for sharing that, and points definitely taken. I think it's still very interesting, and also the things that you mentioned around the consensus. Just out of curiosity, what's actually the finality in average, and does it also apply for any subnet, or does it only apply for the primary network, or how does that work?
Yeah, so it's the same gadget, really, and that's just the Snowman consensus engine. Snowman++ is really just a wrapper around it, but so the finality aspect of it, usually blocks are finalized within 1 second of their production. That's across the network of all 1,200 validators or so. On subnets, because there are typically less participants, finality actually occurs much faster, probably on the order of like less than 100 milliseconds for most subnets. And so that's really just a function of the complexity of the, number of participants, right? Like if you're having to, if everyone's close by and, there's a lot less network communication that needs to occur, like distribution of blocks and everything like that, typically you're voting much sooner to the actual production. Whereas much sooner here is gauged in milliseconds. So it's not like you're switching from a few minutes to a few hours or something like that. So yeah.
Yeah, and as you mentioned subnets, I also talked about that briefly in the video. But as I was talking about it, also like doing my research on it, I didn't like fully understand how I would compare it to. Is it more like an app chain in Cosmos? But then it kind of isn't, because in order to run a subnet validators also have to validate the primary network, right? So then I was thinking, okay, maybe it's more like a parachain on Polkadot, or like a consumer chain that is renting security. But then some people also told me subnets actually don't inherit the full security of the primary network. So maybe you can explain a little bit the shared security aspect and also the validation of subnets.
Yeah. So this is one of the more, I think when I kind of explain where we're at, I think of us almost in the middle between Polkadot and Cosmos in terms of, some of the abstractions there. And the middle there is a very loose term, so I'll go into that. So I think it will first make sense to explain the full process of creating the subnet and what needs to be done. And then I'll talk specifically about, I think, how they kind of compare in some ways. So on Avalanche, when you want to create a subnet, first off, you have to have, some validators running on the primary network. So that typically just means staking on the network. And the current minimum stake amount is 2,000. So to run a subnet, or like to actually have something running, you should stake at least one validator. And then once you have a validator that can participate, you then add or create a subnet. Creating a subnet right now, I think, is one AVAX or something like that. And then you can, once you have that one subnet created, then you can add a chain to it. So subnets can have any number of chains. Most of them just have one. We talk about it just as one because it's easier to kind of understand. And then you can add your validator to that subnet. And so it's different from Polkadot in that it's all opt-in. So if you're a validator participating in a subnet, you don't just like get assigned to it. You have to actively run the virtual machine from that subnet on your node. So if you want to only participate in some things you're, principally aligned with, you can. If you only want to operate things that are running at a certain throughput or something like that, you can do that. Which is important for a lot of people running these subnets. They have very clear ideas of what they want to run, or like they don't want to just run anything. They just want to run the stuff they care about. But the difference with Cosmos, right, is that on Cosmos, when you validate a zone, you just go to that zone and you stake and that's it. Whereas in Avalanche, you actually have to be part of the primary network. And the reason for that goes a lot into the how Avalanche warp messaging works and how that's different than IBC. Right now, by validating, the primary network, you're not providing any additional security at all to the subnet. So it's like its own sovereign, network, just like a zone is on Cosmos. But a lot of people are very interested in that functionality, such that they can they only have like one or two validators. But then if they do something wrong, or like someone posts a proof that they did something wrong, there's some component of their stake in some way could be slashed on the primary network or something like that. But that's not currently how it works. So right now it's really just its own network. Yeah.
Is there plans to implement a shared security feature at some point?
Yeah. So, I mean, I think the big thing there is what is coming up with a standard for how to actually communicate like an offense to the primary network. So you could, out of the box right now, implement something using like smart contracts on the C chain and say like, hey, like these subnets are going to produce proofs and we're going to require all validators to sign all blocks with some sort of BLS key. And, if you produce a block that's invalid by some mechanism, you can post it to the C chain, and then some collateral that every validator posted there will get slashed or something like that. So you could build that out of the box if you really wanted to. But I think a lot of 2023 for Avalanche will include better, making it more seamless to interact between subnets and the primary network for things like this, where, I think for a lot of our engineering resources have gone into just getting subnets off the ground, making sure that they're operating at high performance and allowing them to communicate with each other. And now that is, has come a long way, it'll be about really connecting them with the primary network and making the interactions more seamless. Yeah.
If I look at DeFi Llama, the top applications right now in Avalanche are, well, besides Ava here, which is pretty much on a multi-chain, there's Banky, Trader Joe, GMX. There's a lot more, but like those are the biggest ones with like 250 million TVL, 100 million TVL, 80 million TVL. Are these all subnets, or are they built as smart contracts on the seed chain?
So all of those that you mentioned are currently running as smart contracts on the seed chain. So, and the reason why a lot of them are so popular is because still a lot of the liquidity of the network is on the seed chain. So one of the big things that a lot of people have focused on is trying to make it easier to move between the primary network and subnets. Because right now it's very much like you stay on the C chain or you stay on the subnets. And then there's like some custom bridges people have deployed between the two. So like, for example, the largest subnet application is DFK. They currently process 7 or 8 million gas, or 7 or 8, trillion gas per day, I think is the unit, which is more than BSC and more than Polygon. But their active user count is lower. So it's like, however many thousand that they have. But it really is a perfect example of what subnets are capable of, which is like within a single environment, you have massive throughput relative to any other ecosystem, even within the entire EVM space. And then they have like a kind of bridges deployed that lets you bridge between all sorts of different networks, including Avalanche. So they think about it kind of as like, it's really their community, their chain, their gas token, everything is theirs, right? But you're running on the shared foundation of Avalanche, which provides like all this consensus and networking, similar to how Tendermint, provides a similar functionality for the Cosmos SDK. Yeah. But they're big, like the big launching point and where AWM comes in, right, is how do you then take all the stuff you have on DFK and then move it to other subnets? Like Dexalot recently just launched a subnet that has like a CLOB, right? It'd be great if you could take your assets from DFK and like move it around to different places without using some sort of centralized bridging architecture. So that's really where that comes in, similar to IBC.
I was going to ask, because you just said the majority of the liquidity is sitting on the C chain, so it definitely makes a lot of sense. And I guess on there you have full kind of interoperability between all these applications. But yeah, as you just mentioned, AWM, Avalanche Warp Messaging, which was just announced. I don't actually know what's the current state of it, but maybe you can explain that and how that would be implemented. Is that purely for subnet to subnet compatibility? Can it also be implemented to, let's say, for example, an app chain on Cosmos, or how is that going to work?
Yeah, so Avalanche Warp Messaging was released in late December, so right before the end of the year. And the way that it was released was that it was actually added support with a release around that time, Avalanche Go 195. And there was a successful subnet to subnet mainnet transfer. So there were 2 subnets created using this new virtual machine, which you can go look at online, called the XSVM, so cross subnet virtual machine. And it had one purpose really, which is just to demonstrate how Avalanche Warp Messaging works. And so what it did was it created an outbound message that was relayed to another subnet that recognized that message using all of the primitives. So in terms of like where it is, it's embedded inside of Avalanche Go. You could use it on your virtual machine today, but it is not yet incorporated into the subnet EVM, which is what most people use for communication. So it'd be the equivalent of, let's say like IBC was live on some, it's live on Tendermint or supported in the Cosmos SDK, but then like some zone hasn't activated yet. So I think that's really the description so far of Avalanche Warp Messaging. And that's just because we have not integrated it yet into the EVM, but are actively working on that. So people will start to use it most likely when that's integrated. Now, in terms of how it actually fits into the primary network stack, Warp Messaging is for primarily subnet to subnet, where there's not overlapping validators. So you want to validate that a message came from somewhere and that some percentage of stake signed it, and for going from subnets to the primary network. So you want to go, hey, like I want to take some assets I have on some subnet and bring it to the C chain, because that's where the liquidity is. For example, you are going there from like a low trust to a high trust environment, and the high trust environment, which is not validating any of the subnets, somehow needs to conclude something about the safety of this message, or like the way that it's constructed. And so Avalanche Warp Messaging allows the subnet to kind of produce like a group signature or certificate indicating that some percentage of stake signed some message at some time. And then that can be used by anything on the primary network. So that piece is something that will come into a network upgrade later this year that will allow you to bring things into the C chain. So.
So later, by the end of this year, we'll see the first implementation of AWM on a subnet in production.
Yeah, I mean, we've already seen it on a subnet in production, in a sense, on mainnet, I guess, but not really like a long living network. We'll see it probably activated on a number of subnet EVMs, probably by the middle of the year, hopefully sooner. But
nice.
Yeah, so we're aware that this is a pretty big, you know, the community's been asking for it, and we also agree that it's super cool. And so I think that you know, it'll be integrated into wallets, and that'll take some probably additional time once it's actually live on different things. But we're really excited to see what people build on the primitive once it's in the EVM.
Is that something that, I mean, you're the head of engineering, so is that something that you guys are currently prioritizing from like a technical roadmap, or what?
Yeah, I mean, we have a few teams working on it right now, and have been working on it since the public launch of it, and before the public launch of it, frankly. But it takes time to get quite right to make sure that it fits well within like the Solidity ecosystem. So like, sure, you could like bolt on some like really rough implementation and say like, it's live, like good luck using it. But we're thinking very deeply about how it will actually work within like the Solidity ecosystems and make sure that it feels very EVM-y, if that makes sense. So the complexity, it's actually pretty easy to integrate to a new virtual machine or like a new subnet, because there is no complicated runtime you have to like make sure it makes sense in, which is why we're able to produce like this new virtual machine that used it, right? Because there's just a lot less going on.
Did you look into, I don't know to what degree you looked into IBC, but did you look into maybe some elements also, like maybe you can share a little bit about the trust assumptions, how AWM works? And yeah, I don't know if you mentioned it earlier, maybe I missed that, if AWM could also be, if that's maybe also the goal, to implement it outside of the Avalanche world.
Yeah, so Avalanche warp messaging is particularly optimized for high throughput point-to-point messaging. So IBC is arranged around this notion of like having communication channels between different zones. So like if you don't have a connection to some zone, you're not going to send a message there. So you have to form some connection and then keep that connection up to date with headers from both sides to make sure that you can validate the message if it's a bidirectional channel, right? Because you need to inform the recipient zone that like the validator set has changed, for example, on the source zone, right? Because then you wouldn't be able to actually validate the message correctly. So in Cosmos, like the zones are really serving as light clients of each other. And then when they're serving as light clients of each other, they can actually validate messages that come across that channel. Avalanche, because of the existence of this primary network, actually relies on that knowledge that everyone already has to validate messages. So there is no notion of creating a channel. When you send a message on warp messaging, you just sign it. Like the participants of the network produce like a BLS multi-signature, and then they can send it to any other subnet, maybe one they've never even communicated with before. And then that subnet can then take a look at that signature using the primary network, which already contains all the staking information, and say, okay, these are valid signatures from this set of validators, and that is X percentage of stake. And then the subnet can determine if that percentage of stake and subnet are, interesting to it, and decide if it wants to process that message. So like an example would be, hey, like I created Patrick's subnet and I'm trying to steal all the USDC on some other subnet. So I'm going to like sign it with 100% of stake, but the subnet that I'm sending it to may say like, yeah, we're not going to grant you like a, 10 million USDC incoming transfer. So it's very similar in that to IBC, in that the zones or the recipient zones make their own trust assumptions. Like they're the ones that actually say like this channel or the asset that comes over this channel makes any sense. So from that perspective, it has very similar ideas around trust, which is that every recipient of a cross-chain communication should alone determine if that's valid and what that means. But the actual overhead of that message is from the P chain and like this constantly evolving validator set there, rather than communicating over the channel information about the validator sets that is related. And then the last thing is just that AWM is just for sending bytes. It's a much lower level primitive than what IBC
Okay.
has, which has much more structured information and like fits very nicely into the Cosmos SDK to like route messages to certain components and everything like that. Warp messaging is very much just like, we're going to sign these bytes, and then the recipient subnet can recognize these bytes, which allows us to make this like very EVM compatible messaging format that is very useful for contracts, but at the same time introduces complexity to have like multiple virtual machines communicate with each other, which was a huge goal for IBC, obviously, is to standardize that communication.
Yeah, and I also love to see IBC going out of Cosmos. There's actually a project on Avalanche called Landslide. I had a couple of calls with them. They're actually pretty cool. And what they're building is basically an Avalanche subnet that is also implementing IBC, right? So as far as I understand, it's built on is it built on the Cosmos SDK, or I don't exactly remember.
So I think that they forked some version of Tendermint or something like that allows it to like run on top of a subnet. Now I think, sorry, I forgot your last part of your question, which is like, does it work outside of Avalanche? And like, how does that actually make sense with everything else? Avalanche warp messaging works really well within Avalanche. And that was the goal, the goal for it, right? Which is, we're going to produce some multi-signature and say that these validators signed it. If you're validating the P chain, you can verify that message's integrity like instantaneously, right? Because you have all that stored in memory ready to roll. If you're trying to send that same message outside of Avalanche, well, no one's going to understand what you're talking about, right? Like you're saying these node IDs signed this message. What does that mean to you? Nothing, probably, right? And so if you were going to actually take the messages in their existing format and bring it to other ecosystems, you would somehow then need to like synchronize the P chain's activity to whoever's trying to like recognize those messages in their current form, which I think would be a lot of overhead to do. Because unlike in other ecosystems, on Avalanche, validators don't actually like sign the messages or like sign the blocks that are produced. So like Cosmos, for example, you have all the validator signatures in a block. So you can very easily attest and create like clients. But in Avalanche, there's no notion for that. And that's where we get a lot of the performance gains. It's not having to have like this one-to-many or like end-to-one communication to like share signatures with a single validator producing a block. So having to synchronize that, like the validator membership to other networks, I think would be the real step that would have to be done. And so you could do that if the P chain started to produce like group signatures, like a BLS signature periodically that other ecosystems could then import. And that's something that we've talked about and something that would be really interesting, so that you could just take warp messages out of band and use them, you know, anywhere else. So subnet to many. But I think a lot of people have thought threshold signatures, particularly like TECDSA, is much more interesting for cross subnet communication, because you don't actually have to, or subnet to other network communication, because you don't actually have to track validator membership. You can just like produce a valid ECDSA signature, and then, you know, you could interact directly with Bitcoin, right? Like, are you going to get Bitcoin developers to conclude that they're going to like import P-chain message headers into like the core Bitcoin client? I don't think so, right? And so you kind of have to work with what you've got from the ecosystem, which for the most part is just validating certain well understood signature formats. So
is it possible that the primary network, I guess the P chain in that case, could implement IBC? And if so, is that something that you guys are like, or have ever thought about? Because I had an interview with Emin around a year ago, and he was very passionate about interoperability in IBC. So I shilled him into that idea. I don't know whatever came out of it, but what are your thoughts?
I mean, it'd be really straightforward for a subnet to recognize IBC messages, because it's really easy for any network to serve as a light client of a Tendermint zone, I think. So like it would just listen to the messages just like any other zone would listen to the, you know, channel messages from somewhere else and then make sense of it. The complexity is really the other way, which is how do you get a zone to recognize the output of the messages from a subnet? Because the messages that it can produce only make sense within the Avalanche ecosystem, like the context of having the full validator set. So unless you somehow like communicate all those validator changes, like I mentioned, to the zone, it doesn't really make any sense. Like, I don't know how you would actually authenticate the IBC packet going out of the subnet. And so that to me is the complexity. Like a subnet could eat like messages coming into it, but it couldn't really produce valid things unless you added some sort of trust assumption to the zone that's reading those messages, which I think no one really wants to do. Nor do we, right? Like we don't want to have like some trusted channel producer that like aggregates what's happening on the P chain and then sends that outbound. You really would want to have like some sort of P chain certificate that then like Tendermint or Cosmos based zones could interpret and then determine if a message was valid. So that's my current understanding of the situation. And so I think the lack of bidirectional support or like the complexity around that has like tampered some of the excitement, right? Because it's like, great, like we can definitely take your stuff in, but if you can't like take whatever you brought in and bring it back, it's not really the, you know, solution that anyone, as far as I understand, is looking for. So I think that's really the current complexity.
How is Landslide doing it then? Because I know they're trying to do it, but like, do you know how they try to?
I'm not sure. They may. What you could do is try within the subnet to actually produce signatures that are not warp messaging.
Okay.
So what you could still do is give the validators within a subnet, because they can run anything, right? And this is really the excitement around subnets, is you can run, and similarly to what it is in zones, right? Like you can really functionally run anything. So if you assign each of those validators some sort of key, or you just have them reuse their BLS key, and then you basically sign the block or do what Avalanche consensus doesn't already do, then I think you could accept those signatures. But then you'd have to have some sort of shim to the Cosmos SDK that can validate like header changes or state changes using BLS multi-signatures as opposed to whatever. Or maybe they just create Tendermint headers, but then use Avalanche for the actual consensus part of it. So like you can do it, but it's not like a native component of AWM. Like AWM right now, as I mentioned, doesn't really make a lot of sense outside of the ecosystem because of the way it uses the P chain. And then you could try to achieve bidirectional IBC support by like adding additional signatures to blocks on Avalanche such that a zone could serve as a light client, because that's what's required for IBC. So that's my guess of what they're doing. I think that it would be interesting. If they look for that.
There's a comment from Sunny. I guess it's the Sunny Agarwal, co-founder of Osmosis, who is saying that the issue here is that basically what you just mentioned, that you guys need an efficient light client, which you currently don't have. But I don't know, maybe there's a way.
We do have a light client, but it's not really attributable. So like what you would have to do is like every validator on a zone would like have to run like Avalanche consensus on top of the subnet that they're trying to ingest things for, which, you know, like it's pretty shitty. Like I think the better thing is, right, like is if you have an attributable message, then you don't really like, you basically are creating a light client, but it's not really an Avalanche thing at that point. It's just like signatures. And so, yeah, so I think some people are commenting that Landslide is building that light client. So very curious to see, you know, how they do that. And I think that's really the missing piece to have like an Avalanche IBC connection. And I think actually Zaki presented on this at Summit last year in Barcelona of like a way to do that. The issue at that time was that signature, like validators only had RSA related signatures, which we use for like the some of the voting stuff, which is, as anyone that knows RSA is like, you're not producing small signatures at that point. But now that validators will have BLS keys registered, it would be much easier to produce like some sort of like multi-signature light client that would make sense outside of the ecosystem. And so I think that would be the really cool connection with IBC, is if, you know, it sounds like Landslide is already working on something like that, but a way to produce a more efficient light client. But very briefly on the light client point, we actually in the last release put out this like test peer client, it's called, which will run Avalanche consensus or basically run anything on top of a particular Avalanche network and communicate natively. So you could run like a light client process without actually verifying or executing any blocks, but then it just like performs consensus and verifies and accepts blocks, which we think would be useful for relayers and stuff like that are trying to produce these signatures. But sorry, that was a lot.
No, I feel this is a very technical and very productive podcast, even though I'm not technical at all, but it seems like you and the audience is. So I appreciate it. And hopefully there's also some follow-ups after that where, people also that are commenting right now and discussing can get in touch with you and see what can be done.
Yeah, I mean, so like at a high level, like at least the people I've talked to are super interested in finding ways to communicate natively with everyone, right? As long as that communication doesn't involve the addition of like additional trusted intermediaries, right? So if there's a way to like natively connect a subnet and a zone, you've just now summed the value of all the activity and development going on there, which is really awesome, I think, for both groups, right? So there's definitely interest in finding ways to make it tangible, and if we have some sort of efficient light client from a subnet, that could probably be used for a lot more as well than just connecting to different zones. So I think there's a lot of interest in that. So I'm sharing this not because I like want it or not want it. It's just I want to make sure that the complexity or like the gaps in the technical story are clear so that people that are wondering or thinking about this can understand that and then maybe contribute back if they are passionate about making that work. Yeah,
I think Lee also summarized it well. Really likes the approaches. I think like in the end of the day, there's a lot of different ways and a lot of different flavors out there. But I think you guys also have this mentality that there's rather synergies to be explored and not too much, tribal. We're gonna take over mindset.
Well, I think that in a lot of this, communities typically work well with each other that share at least some similar principles, right? And I think some people laid out their principles 5 years ago and will never change them, and that's totally okay, right? I think our principles are pretty much tech above all and science and innovation above all. Like if there's a new idea that comes out, we'll look at it. Like it doesn't really matter where it came from or which ecosystem. If there's a quote somewhere is like, if someone shares new information with you, what do? Well, I change my mind. And we're very open and receptive to new ideas that are better than what we may have been thinking about. Whereas I think not everyone is similarly open. I think what Cosmos and the ecosystem there has very similar ideas there, which is let's just make something that works and that people could use. Like the actual ideas we had about it or shared, at any time in the past are irrelevant if we come up with some better way to do something. And that openness, I think, is critical to building blockchain networks in this decade in particular.
Yeah, and actually, as we talk about it, and Sunny was just here, I saw this tweet actually this morning or yesterday, that there's an integration of AVAX directly on Osmosis, and there's also an upcoming Twitter space tomorrow with Luigi, who is the head of DeFi, Luigi Donorio De Meo, who is working with you. So that's cool. I'm going to actually drop the tweet in the chat so people can check that out.
Cool. Yeah, I'm sure. Yeah. Is it using Axelar or what is it using? Because I know Axelar has an integration with Avalanche, and I could understand that once it's on Axelar, you could IBC it out to anywhere else within Cosmos.
Yeah, could be. I mean, Sunny, if you're still in the chat, you can drop a message. But as far as I would assume, it would be through Axelar, because Axelar is like the canonical bridge on.
Unless Osmos also built a light client, in which case I'm happy to take a look at that too.
Yeah. Okay. Yes, via Axelar. There we go. Cool. Okay, I want to change a little bit the topics. We're almost at 45 minutes, but I have still some questions, and I also see great questions in the audience around different things. One thing that I also mentioned in the video was regarding AVAX's kind of like distribution. AVAX has a max supply, right, of 720 million. Half of it was allocated as a sort of security budget. And currently there's an inflation or like emission rate of, I don't remember, like was it 6 or 7%, something like that. So my question is, once we get towards the end here with, the security budget, how do you think this will play out? What will replace that? And how do you incentivize validators?
Yeah. So, I mean, with a, also first being said, I'm a technical guy, so I don't really delve into like crypto economics much. So, and this is in no way investment advice or anything like that. More so talking about the network as a whole. So one of the, really interesting things with the network is because a lot of the staking happens on the primary network, right? For both Avalanche and for any subnet. The network itself will continue as a place to like kind of orchestrate this platform of platforms, right? Like the whole point and like one of the big differences I think with Avalanche and Cosmos is the deeper tie-in with subnets to the primary network. Maybe not from like an execution perspective, but from the coordination perspective, right? So if you create a subnet and you make it an elastic subnet, which we haven't really talked about, and I'm not sure that we'll have time, but elastic subnets are a way to transition a normal subnet and then add custom staking and custom rewards to it. Well, all of that happens on the primary network. So all the rewards, everything like that. And so the vision for Avalanche, probably similar to in some way it is for Cosmos, right, is on Avalanche network, you'll be a validator, but you may be staking and participating and earning yield on, 5, 6, 7 different subnets. And so Avalanche at that point, let's just say that emissions are 0 in year 2100 or wherever the hell that will technically occur. At that point in time, what would happen is that it almost becomes a membership. Like to earn certain rewards on different subnets or like participate in those subnets, you have to be a member. And so we would think that over time, the reward mechanism for those subnets and everything like that will, become so much more than just the primary network, that the tie-in to how it actually works on Avalanche is going to be more so about like, how do you participate in this subnet economy rather than purely just on the primary network, which is what, most people use today is just the C chain, right? But if to actually participate in the network, you have to be a part of the primary network because of what it enables you to do with warp messaging. It changes kind of the way to think about that from just being what's needed and earning like fees on just staking to really more of the pass to really interact with this ecosystem. So the whole idea is, right, you want to launch your own blockchain, but you don't want to reinvent your consensus. You don't want to reinvent your networking. You don't want to like reinvent cross-chain messaging, right? That'll take years. And as it gets more complicated, will take even longer to replicate existing functionality. But you have a community, you're trying to launch your own sovereign blockchain, Avalanche, I think, is a great fit for that because of the generality of the subnet runtime and what you can do with it. But to do that well, it's deeply connected to the primary network.
Yeah, as you mentioned, like launching your own project or launching your own blockchain, I'm wondering if you've been following any of the innovations in Cosmos around replicated security or interchain security, and also mesh security. I don't know if you looked into that concept, but what are your thoughts on that?
Yeah, I mean, like it all comes down to this, right? Like if a virtual machine can produce some sort of proof of malicious activity, whatever that is, and then whoever's participating has funds locked somewhere else, you can penalize them, right? Like I think that's the similar, like the main notion of mesh security, and a lot of the ideas around shared security, right? Like you don't necessarily need to validate everything that's happening somewhere else, as long as you have a way to make like a short, clear, standalone proof of that activity. And so because warp messaging is so low level, like you could probably take many of the primitives and bring them elsewhere. Now, instead of having like a proof, which may, be a block header or something like that, really what it would take is all the validators or like participants on the subnet signing some message indicating that something happened. And then anyone that reads that message in could then slash or penalize the validator of that. So I think the ideas that the Cosmos ecosystem has around mesh security are very applicable to what subnets are. And I think a lot of the desire for subnets, and like one of the big things people think is missing, is a way to rely on more shared security. So if there is like kind of a big interest in this and it ends up being, the way that a lot of people do this sort of stuff, I think subnets, could totally adopt some of those ideas around mesh security. Like, let's say there's like a big liquidity hub as a subnet. Well, what if to like stake or like earn certain power within a different subnet, you had this, lock up some tokens there. And then if messages were sent, over AWM to that subnet, it would, take those funds or distribute them to somebody, right? And I think that's a lot of the ideas of mesh security, as far as I understand it. So
yeah, I think also the end game for for mesh security is that you have a network of like chains that all secure each other, right? So you have a consumer of shared security that can be a provider at the same time. So you just have this interconnected network of shared security chains. But
I think the complexity for us is really just within the runtime. We have a much more generic runtime, I guess, than I think what some of these other ecosystems have. And so creating like a standard fraud-proof framework, given that generality, will be complicated to get right. But that is really similarly on the vein of like having light clients and everything like that. It is very important that you have some standardized way to probably do this. Otherwise, what if your mesh security protocol, you had to implement 15 different types of fraud proofs check? People probably aren't going to want to do that. So whatever that means, will be interesting. And I think over the next year, we'll share a number of kind of innovations we have planned, or like ideas we've had about improving Avalanche consensus and the connection to some of this fraud provable story at that time. But I think you could build it now if you wanted to, using just warp messaging and some sort of signature that you produce over some bytes. But I would say that it's very unstructured at this point. And I think, just because we're getting to the end here, I think one of the big areas for interaction between the Avalanche and Cosmos ecosystems are really alignment, opt-in alignment on some sort of messaging specification. Like, some of the components of IBC may not make sense for at least every subnet in Avalanche, but I think the notion of having some structured communication is obviously interesting. And, if you have different virtual machines that are interacting with each other, right? Like, you don't want to have 10 different encoders written. So, yeah.
I feel like you and the whole engineering team, you should definitely come to Cosmoverse this year, late September or sometime in October, which is going to happen in Istanbul. Don't know if you saw the announcement, but that's where also all the development teams in Cosmos are going to be assembled. And last year we had also a hackathon subsequent to the conference, and that's where they developed the prototype for mesh security. So yeah, would be cool if you guys can make it this year. You also, I'm sure you know that, but obviously you have a giant community in Turkey, obviously with Emin being, having a background being Turkish. But yeah, I have two more things before we get into maybe one or two questions.
Sure.
One thing is governance. I also shared this in the video. I also made a tweet that might also be a hot take. But I think like one of the reasons why you guys are moving so fast and leave a lot of the competition behind in many aspects, including Cosmos, obviously, is that there's currently no on-chain governance framework. So maybe you can explain a little bit on what the thought process here is and what the plans are to potentially establish that in the future.
Yeah, I mean, I'm not sure that it's like explicitly like we must have governance or must not have governance perspective. I think it's just outlining the priorities with the limited development resources that there are in the ecosystem. And so when you ask people generally, like, what's more interesting to you, is it having governance and voting on certain system parameters, or is it having subnets that can talk to each other? I think 99 out of 100 people would say subnets that can talk to each other. So it's not that I don't think anyone in the ecosystem is pro-governance or anti-governance. In fact, I think many of them are pro-governance for a lot of the system parameters, like what's the staking amount and like what's the delegator amount. I just think it just hasn't happened yet from that perspective. The consensus algorithm actually used in Avalanche is super compatible with voting, which is interesting. So when a vote comes up, so think of it like a block, right? Let's just say you're voting for rewards on the P chain, because this is something that already happens today. Based on your observed uptime of other nodes, you bias your sampling to a certain preference. So like if you observe someone not being online, you'll start off saying voting for blue. But then if someone else says, I've observed them uptime, you vote for red. Well, very quickly, the way Avalanche consensus typically proceeds is it proceeds to the one that has the strongest preference that starts out, if there is a preference. So if you had governance, you could do the same thing and just bias the preference to the proposal that your node is preferable to. The really interesting outcome of that is that it is private voting. No one knows the true preference of any validator. So you could vote privately on different topics that get ratified based on if they're accepted or rejected by the network, which has very interesting outcomes. So like, you can't necessarily hold validators accountable if you delegate to them. But at the same time, if no one knows what your preference is, most people would say that that is more likely to end in like a true vote, like that actually expresses the true preference of the network. So yeah, I think there's a lot of things that are compatible with Avalanche consensus to do voting. It just hasn't been prioritized from the perspective of what the community is interested in. Yeah.
No, I think that makes sense. And, in Cosmos, I'm not sure how much you've been following that, but Cosmos, many Cosmos chains are quite political these days. We're also known for the, DPS that's hitting all-time high after all-time high, drama per second. So there's always a new proposal that causes new discussions. And but I think, sometimes for us as the Cosmos community, it's also interesting to see that maybe we're like overdoing it, and like exaggerating a little bit with detailed governance stuff. And like, that's how you don't move fast in the end of the day, right? And that's how things become political and you divide the community a little bit. So
I think it's a grass is greener story usually, right? Like, it's probably also super interesting that you can get the community to engage so deeply in the conversations, right? Like, as opposed to having an entirely passive community where it's just like, whatever happens, which is the case on a number of different projects, right? But I don't think blockchain governance is a solved concern. And I'm not quite convinced that like straight up democracy in with public proposals yields, at least some people are concerned that they may not yield the best outcomes from development from it. And so a lot of people, like, for example, Polkadot, I think, has like these committees, which are very different, which like ratify things on their own, and they're like more nominated, so they don't vote on every proposal. Is that better? I'm not quite sure. So I think, there's a lot to learn here in terms of, I don't really have an answer as much, but I
think the biggest benefit and like the biggest plus that, even though we have this drama sometimes, is like in Cosmos, you have a very active community of contributors, right? Like people that actually through on-chain funding or on-chain governance can contribute, whether it's code or, we did Cosmoverse 2 years ago for the first time, which is a physical conference. And the first sponsor was the Cosmos Hub, right? Which is cool. That's really, really cool. There's an accelerator DAO now that's probably going to get funding to fund then development on the chain. So I think like there's a lot of like benefits from it, but at the same time, it all comes with downsides. And I think one of them is that sometimes Cosmos can't move that fast, which, if we remember, 2 or 3 weeks ago, you guys made a giant announcement, right? Which is the Amazon partnership. And I have not looked too deeply into it. I've heard everything by now from, this is just clickbait and marketing, to this is a serious partnership. So I wanted to ask you about that before we get into some questions. What is that partnership actually about? And maybe you could explain that a little bit.
Yeah, so that partnership with AWS is really about helping their customers adopt new and exciting technologies in blockchain. And what they will do is bring Avalanche to their, massive customer base on AWS. And then the hope is that through that engagement with their customers, we will together develop interesting tools that would be useful both to the Avalanche community and to whoever's using Avalanche. Now, the reason why they're interested in Avalanche primarily comes back to they're very customer focused. So they told us that their customers have been asking for easier ways to integrate with Avalanche. And so they just listened to their customers and were very interested in trying to find ways to work there. And the reason for that is the subnet story. Subnets are a really huge enabler for a lot of enterprises that are looking to adopt blockchain, right? Like they've heard the Solidity story, right? Like, they can write a smart contract, but they want to go one step further. They want to like integrate blockchain more deeply into their business rather than just calling out to a smart contract. And for many of them, that involves building a chain from scratch. And so, we have in private development some virtual machine SDKs that make it easier to build a blockchain from scratch. And so that narrative tied in with having to run your own network and everything like that is very compatible with what services and products AWS has to offer. So there's a deep kind of alignment on what helps different enterprises get started. And I think one critique we've heard is like, oh, blockchain network working with centralized cloud provider, like that's terrible. Well, the story is, the true thing is, like, for many of these enterprises, they want a provider that they can trust, government center. Like, we already have a partnership with Deloitte, right, at AWS, right? As much as people may want it, Deloitte doesn't want to run their node on some box in some guy's house, right? They want to run it on a cloud provider that they trust and are willing to accept the trade-off that entails. So to get adoption from different people, this is a really important trade-off for them. Now, will there be other cloud providers and like other more decentralized things people use to launch subnets? Yeah, I really hope so. But for some clients, they really want to work with the people they already work with and trust. And so AWS working with their customers and helping us, really interact with them in different ways is really critical to that.
There's also another interesting partnership you guys have with TOG, which is an electric car manufacturer in Turkey. What's that partnership about? How much do you know about that?
I know that I probably can't talk much about it because I don't know what's under wraps and what isn't, but I know that they're very interested in using blockchain technology for all aspects of a modern car architecture platform. And given the familiarity of a lot of people in Turkey with Avalanche, I think it just made a lot of sense for them. So I think you'll start to see. I'm not going to speak specifically about any of the particular things that they're going to do with it, but I think it's just an example of more enterprises and brands really getting into blockchain, but really saying, yeah, running a smart contract somewhere is just not enough for us. We want to have more control and deeper control of what we do, even if it takes a little bit more time to get started, which is similar in principle, again, to what the Cosmos ecosystem has been preaching. And the reason why there's a lot of zones that are so successful is the ecosystems themselves want a bigger piece of the pie rather than just running a smart contract. And that applies to enterprises too, which may not even be able to run a smart contract somewhere for whatever legal and regulatory reasons.
Let's do some community questions to wrap things up. Actually, after I made my video, a lot of people have asked me that. And I should definitely ask you around the Nakamoto coefficient and the decentralized kind of like validated infrastructure. So maybe you can touch upon that and explain how that works.
Yeah, so I think this is just a standard look at like how much stake a particular validator has and like how many validators it would take to halt the network or something like that. And so just like most proof of stake networks, I think there's a pretty long tail, right, where like the top 30, I think on Avalanche or so, validators have 33% of the stake weight or something along those lines. Now, I think liquid staking and what like Banky's trying to do there is trying to flatten that a bit. And I think there have been meaningful changes to that distribution as different liquid staking things have grown. But really, one thing that'll be more interesting is Core, which is the Avalanche native wallet that Ava Labs runs, doesn't actually support staking yet. You have to use the old Avalanche wallet, which, let's just say, doesn't help you really understand which validators are doing well and like maybe what ones you should delegate to. So people just kind of randomly pick probably the ones that are the biggest or have the lowest validator fee. Core will totally reimagine this experience and make it easier for people to opt in to helping to decentralize the network more. And I think that that'll be a big improvement there. But I think one story similarly is subnets, right? Like subnets tend to have many less validators does that make them insecure or secure or like, whatever? Well, the Nakamoto coefficient on subnets is probably much lower than the primary network, right? And so helping people stake to subnets and elastic subnets in particular is going to be a huge effort in 2023 for us to really help to turn a lot of these subnets from a proof of authority network into a true, community network. So, and then they can benefit from having, as many validators as up to the primary network, right? So they can be much larger than a couple hundred if that many people want to run validators.
And the minimum stake required is 2,000 AVAX, which is currently around $40,000. And is there a minimum for, I think it's 25 AVAX, right? If you want to stake or delegate.
Yeah, delegate is 25 Avalanche, I think. Yep. Yeah.
All right. And then you also just have to choose your validator and then delegate to them.
Yeah. But the cool thing, what will happen is with elastic subnets is that when you like convert a subnet into an elastic subnet and you have the token that is used by that subnet for staking, you can also delegate on a subnet too. And then it's up to the subnet to determine the minimum stake amount and the minimum delegator amount. So you as a subnet could say, hey, like we're going to enable staking of our custom token and then not allow any delegators at all. Like maybe it's a minimum 100% fee. And so anyone that delegates will have to be a validator. Or maybe you want to really encourage delegators for some reason, and you say your max delegator fee is 0, right? So we're very interested to see how people play around with how they're going to engage their communities to help secure the chain. And it's really critical that it is up to them. So the Avalanche network imposes very few restrictions on like how you actually can organize that, other than knowing that your assets are there and safe, which is a big difference, I think. So when you stake on Avalanche, your funds do not go to the subnet. You stay purely on the primary network. So, if the majority of funds are on the primary network, the funds that are actually being used for staking are not the security of the subnet, it's the security of the primary network.
Yeah.
So you could go stake on random subnets you've never heard of, and you don't have to have any fear that you're going to lose your funds by participating there, which is a very large difference from both from Cosmos, I know, which involves you taking funds and actually bringing them to that chain. And so then if, let's say, a chain was to halt or have some security issue, no problem to you.
Yeah, I mean, sure, I understand the point, but I think also like at the same time, you could make the counter argument and could say if something happens to the primary network, every subnet would be down, right? And then,
so I mean, the subnets actually run a separate consensus process. So if the primary network had issues, like subnets would just continue. You just would not be able to update the validator set. So they kind of like go into like a maintenance mode per se, where like they'll still go and still run their own consensus and everything like that. They just won't get any updates from the primary network. But if that, if there's a deeper issue with the node itself or something like that, obviously you'd have a problem.
Yeah.
But just to clarify that point. Yeah.
Yeah. But no, I think, in Cosmos, obviously the primary approach was or is to build a sovereign app chain. And we've seen with the collapse of Terra that this is actually a smart design, because the Terra collapse didn't affect downtime of Atom or Osmo. But now also with shared security coming, I think there's more options. Let's do two quick ones, and then I'll let you go because I know we're already over time. There's a good one from Mr. Anonymous. Will AWM allow subnets to also communicate with the P and X chains or just the seed chain?
Yeah, so I mean, theoretically, it would allow it to communicate with any chain on the primary network. I think initially it'll probably be the C chain and then maybe the X chain. The P chain, I think the goal will be to keep the complexity there simple. So I think the hope would be to primarily keep that activity on other chains, but there's nothing that prevents that in the future. I think that one could be particularly interesting, that connection with fraud proofs. Like if the fraud proofs are where all the stake is kept on the P chain, it may make a lot of sense to connect the two. So, so theoretically, yes. In terms of priority, the C chain will be first, I think, because most actual interesting interactions happen between the C chain and kind of EVM based subnets.
Last one, I don't know how much you can comment on that, but how do you think the token value accrual will play out between P chain, C chain, and subnets?
Yeah, I'm not going to comment on that one if that's all right. Yeah.
But I think, I mean, we said earlier that currently most applications are running on the C chain, right? So I guess the current, like as of now, the main value accrual comes from the C chain, but with AWM gaining traction and elastic subnets, you said earlier, I think
I'm excited for Avalanche, the network. That is this blockchain of blockchains, just as similarly Cosmos is excited about zone of zones and everything like that, right? And so I'm here because I think that's where a lot of the technical work is happening, and building custom virtual machines that take advantage of Avalanche in every way are super cool. And so I really hope that's where a lot of my effort is going in terms of engineering interesting things and experimenting, but I can't comment on any of that particularly and how that applies to the token, which
no
again,
financial advice.
Engineering guy here.
No financial advice, but Patrick, thank you so much. I think we should do this again, and maybe also with a Cosmos engineer, because I can't get in a conversation with you about technicals, but maybe Sunny, who says that if he wasn't working on osmosis, his passion research project would be designing a web of trust version of Avalanche consensus. So that could be a future episode. Also, maybe with Jack Sampolin. I don't know if you guys are in touch or talking, but I think this was really good, really productive. Appreciate your time, and thanks for joining.
Yeah, thanks for having me. Happy to hop back on in a group setting or something like that to discuss, other topics. Like I said, I think the principles of the communities are pretty aligned, and so I think usually those lead to really interesting conversations on, just good and bad ideas in general. So or just good and good ideas. It doesn't have to be bad ideas.
And Sunny is hopefully gonna find that day to build a light client for Avalanche, so we can see.
Yeah, I'll find the day to review it, or maybe I'll find the day to build it too. But we'll see.
Or you all just come to Cosmoverse and you do it there together.
Yeah, fair enough. Yeah, we'll see.
Let's see. All right, Patrick, thank you so much. Also, everybody for the questions. We'll keep in touch and see you soon. Cheers.
Yep. Thanks. Bye.